Take a look at question 7. We have a polar coordinates question. Curve C shown in figure 1 has polar equation r equal to a open bracket a plus sine theta, where a is a constant. The tangents to C at point A and B are perpendicular to the initial line. Use calculus to determine the polar coordinates of A and B. What does it mean by, tangents to C at point A and B? So let's draw the tangent lines first. So it will just cross point A and B. Okay, so let me just shift it a bit so that we can see that it is a tangent line. Next, they say that this point must be perpendicular to the initial line. That means it would be like that. So we are looking at vertical lines. So we have two vertical lines. And we want to find polar coordinates for both A and B. Moving on to part B and C. The curve C models the perimeter of the surface of a swimming pool. Given that, according to the model, the distance across the pool from A to B is 10. Show that A is equal to 20 root 3 over 9. And use algebraic integration to determine the surface area of the swimming pool. So what does it mean by distance across the pool from A to B is 10? So that means from here to here, that would be 10 meter. Now we can begin with part A. So because we are looking at vertical lines, right? We cannot find our dy dx because dy dx for vertical lines is essentially undefined. But what do we know? For vertical lines, our dx d theta would be equal to 0. So we can find our polar coordinates for A and B using this equation. Dx d theta equal to 0. So let's begin. The equation that we have here is r equal to A open bracket 1 plus sine theta. Because we have to find dx d theta, so let's use the definition of x in polar coordinates. X is equal to r cos theta. Okay, so let's define this. This is equation 1 and this is equation 2. We will substitute 1 into 2. So substitute 1 into 2. So we will get x is equal to a1 plus sine theta multiply with cos theta. Let's begin by expanding the first bracket. So we will get a plus a sine theta. And this one would be cos theta. Expand it again and we will get a cos theta plus a sine theta cos theta. Let's recap our identities. So we know that sine 2 theta is equal to 2 sine theta cos theta. So here would be 2 sine theta cos theta. And out here, what we can do, we can multiply this with a over 2 in order for us to get the coefficient a. And let's copy a cos theta back over here. Now, let's substitute with the identity. So we will get a cos theta plus a over 2 sine 2 theta. That is our x. Now, we can proceed with our differentiation. Dx d theta is equal to negative a sine theta plus a over 2 cos 2 theta. Now, let's differentiate 2 theta. That means we have to multiply by 2. Simplify this, we will get negative a sine theta plus a cos 2 theta. We will equate this So equate dx d theta with 0. So we will get negative a sine theta plus a cos 2 theta equal to 0. Let's use another identity. We want to make sure that we have our equation solely in sine. So cos 2 theta is equal to 1 minus 2 sine squared theta. This is what will be substituted into our equation. So negative a sine theta plus a. This one would be open bracket 1 minus 2 sine squared theta close bracket equal to 0. Let's expand and simplify this. Negative a sine theta plus a minus 2a sine squared theta equal to 0. Let's rearrange. We will get 2a sine squared theta plus a sine theta minus a equal to 0. So essentially what I did was I bring everything to the right hand side to make my coefficients for sine squared and sine to be positive. Okay, now I can divide my equation with a, and I will get 2 sine squared theta plus sine theta minus 1 equal to 0. So we have a quadratic equation. We can use our calculator to find the values. Let's see, okay. Menu equation function polynomial degree 2 and key in the coefficient 2, 1 and negative 1. So the first value, give it some space. So sine theta equals to 1 over 2. And the other one is sine theta equals to negative 1. Let's work our way up so that we can show our working. So let's make both equation equal to 0. So here would be 2 sine theta minus 1 equal to 0. Here we will get sine theta plus 1 equal to 0. So these two would be our factors. So write down our factor. 2 sine theta minus 1 and sine theta plus 1 equal to 0. Now we would like to find the value of theta for each category. Okay, so let's first begin by sketching our sine graph. Let's take a look at our domain first. Theta is in between negative pi until pi. So theta is in between negative pi and pi. Is it inclusive? It is inclusive, only pi. So let's sketch now. Okay, there we go. Because we want to consider only from negative pi until pi, so it would look like this. There we go. So that is our graph. Okay, so here would be that's pi, that is negative pi, and here would be negative 1, and here would be 1. So where is it do we have negative 1? Okay, so we have negative 1 when it is pi over 2. Theta is equal to negative pi over 2. That is the only value within this domain when your sine theta is equal to negative 1. Now let's take a look at our other equation. Sine theta equals to half. That means we are looking at this part. So we know that we will get two answers, one here and another one here. So this is quadrant number 1 and this is quadrant number 2. So let's start by finding our quadrant 1. So for Q1, it would be theta equal to inverse sine half. So this is equal to, okay, make sure that your calculator is in radian mode. My calculator is currently in degree mode, so I'm going to change it to radian first. So inverse sine half is equal to 1 over 6 pi. Now, for our second quadrant, it would be theta equals to pi minus 1 over 6 pi, which is equal to 5 over 6 pi. Okay, let's zoom out and take a look at our figure. Okay, so the drawing. We have a theta equals to negative pi over 2. So that means, okay, we are looking at this point because negative direction by pi over 2. So that's not point A or B. Another one is, okay, theta equal to 1 over 6 pi. So it would be here. So this is for point B. Now, quadrant number 2, 5 over 6 pi. So that would be for point A. Okay, so this would be rejected. Okay, in order to give the answer in polar coordinates, what do we need? We now need to find our R. So let's key in back into 1. Sub sine theta equal to 1 over 2 into equation 1. So R is equal to A, open bracket, 1 plus 1 over 2. This is equal to 3 over 2A. So that is our R. So what is our coordinate? So A is equal to 3 over 2A, 5 over 6 pi. And for point B, it would be 3 over 2A, 1 over 6 pi. That's it. We are done with part A. For B and C, it will be the next video.